Hey, chemistry students. Mr. Ferguson here.
And Mr. Hunter again.
And we're going to do the video for 2.3. We're talking today about properties and changes of matter. So this unit's all about matter.
Our first objective is to recognize and distinguish between physical and chemical properties of matter.
And then once we learn to do that, we're going to be looking at different changes that matter can go through and identifying the changes as either a physical change or a chemical change. So let's get started. So we're going to talk about properties. And properties would be those characteristics that are measurable or observable. The physical properties are observed without changing the substance. So you still have the same substance at the end as you had at the beginning of a physical property. And we've been talking about in our chem think, the difference between substances, different kinds of substances, elements, compounds. Either one of those can be a substance. We learned that in 2.1. And when you when you observe a physical property, you still have the same substance when you're done. So I can look at Mr. Hunter's shirt today. He's wearing a black shirt. I just observed the color. That would be a
physical property. Yep, there we have color so far.
I can look at something and say its shape. Now my pen is a cylinder. That is a physical property. The appearance of something. It looks shiny. Physical property. We can get into measurements that we can make for physical properties. Like we can measure the temperature at which something melts. We can measure how long it is. So temperature is a physical property. Length is a physical property.
So for those who are wondering, the L, T, and M, length, temperature, mass.
And we can look at density, which involves both mass and volume, and there's actually a pretty exhaustive list. If I read them all off, there's 50 or 60 at least physical properties we can
probably
look at.
One more that's useful would be boiling points, melting points, and freezing points. But
okay, let's actually go into there a little bit more. Thanks, Mr. Hunter. So here's a diagram, and let's say we're looking at this solid material here, and you can see that the atoms that it's made of, the particles that it's made of, are very closely arranged. They'd be wiggling around a little bit, but not moving around much in terms of going from point A to point B.
So they are vibrating in place, is how the chem think assignment talked about it.
Vibrating in place.
At home, you should probably be at least copying something similar to what you see on the screen down, just to have an idea.
Spots close together that represent the solid.
Exactly.
It's ice. Now, if we begin to add heat to the ice, we're going to see something happen when we get in the neighborhood of 0 degrees Celsius. It's going to change into liquid water. It's going to begin changing anyway. And if we continue adding heat, it's going to melt. So we call this temperature, 0 degrees Celsius, the melting point temperature, which is a physical property of water. It melts at that temperature. But the interesting thing, if we go back to the definition of a physical property, it's something you can observe without changing the substance. And I know probably some of you are thinking, I don't understand this. You just changed it. It's a liquid now, it was a solid. Mr. Hunter, how can we change it but not really change it? You know what I mean? How do we explain that?
I mean, I guess if we look at the molecular level of this thing, we are still having water, H2O, but if you take a look at those spheres, they actually start to slip around and move around something else. So it's physically different. It went from being a solid to a liquid, but on a molecular level, we're still looking at the same compound that's just moving around. The exact same
little particles. They just change how much they
can move. Their degrees of freedom are more, so they can go from the top of the beaker to the bottom. Where in the ice, they're kind of stuck at wherever they're stuck.
But they're not different particles.
No, they're still H2O, and they're still happy as can be.
The same thing would happen if we heat it up to 100 degrees Celsius at standard pressure. Those molecules get even more freedom. Now they're zipping around in here as gas particles, but it's still the very same. This particle and this particle and this particle are identical.
Still
That's the
H2O.
idea of a physical change.
Now, if you were going to ask you a question about this, sorry to interject, but how would we solve the spacing between these atoms would be changed as we change their states? So how does the spacing between the ice atom differ from the gas atom?
It's bigger in the gas.
Yeah, there's a lot
The
more
spacing
space.
is bigger, but the particles are the same, so it's still a physical change. Okay, now if I shrink this. Okay, so we're going to move on to the other kind of property, the chemical properties. You are observing a chemical property when a substance is changed into another substance. So basically, you think of it as, the before and after. What you have before the change is different than what you have after the change. Then it's been a chemical change. So we've been learning to use Bunsen burners and doing things with Bunsen burners. This year, we're going to take a look. So we're going to blow up our little Bunsen burner.
Maybe.
We're going to bring it to the front. There we go. So, in a Bunsen burner, we already know the fuel, which is methane gas, comes in through the tube. And then we open the air vent and we allow O2, which is part of our atmosphere. And there's other gases too, but the O2 is the one that reacts with the methane. And the reaction we see is in the form of that flame that's coming out the top of the burner. But if you were to collect the gases that are leaving that flame and being carried out into the room, you're not going to find oxygen or methane. You're not going to find CH2 or CH4 or O2. You're going to see the gases that are mentioned up above there: carbon dioxide and water, and maybe even some carbon monoxide, and you may even have some nitrogen oxides that are being given off. So those are what are called the products of the reaction, and in chemical terms we'd say that the O2 and the CH4 were the reactants, and they changed into those things up above there. So we have different chemicals coming out the top of that thing than we had going in the bottom. That's a chemical change.
Yeah, so you can see we had CH4 plus O2. That little arrow I drew means yields, which means something chemically has happened. It's rearranged the atoms to CO2 and H2O, and that is what shows a chemical change, the rearrangement of the atoms.
So one of the characteristics you'll see in a chemical change when these new substances form, they don't have the same properties. That's one of the ways that we know they're new. If you gathered up the gases that came out the top of that thing, the CO2, the H2O, and the carbon monoxide and the nitrogen oxide, and you fed them back into the bottom of a Bunsen burner, you could try all day to light it. They don't burn. They are different in their properties than the
fuel
methane
and the O2
and the oxygen. So, carbon dioxide is used in fire extinguishers. It puts fires out. Water puts fires out. O2 and CH4
make fires.
Are combustible. They make fires.
Like that Pringles can we popped.
Okay, so fundamental change in properties. All right, so let's take a look at some examples of chemical properties. It's a shorter list. The first keyword is going to be the word reacts with. The basic chemical property of something is, does it react with something else? One of methane's chemical properties is methane reacts with oxygen.
Also known as reactivity of a substance.
Some things like to react with virtually any other chemical they come in contact with. Other substances are a little more selective, and some really don't like to react much at all. Carbon dioxide is non-reactive with oxygen. It's not going to burn. And another word that we use is just kind of a special kind of reactivity would be flammability of a substance. Does it combust in the presence of oxygen? So something can be flammable. That can be one of its chemical properties, flammable or combustible.
Yeah, sorry. Flammable is harder to spell.
Okay.
We also have something known as toxicity.
How does it affect living tissues? Is it poisonous? And how much of it does it take to cause a poisonous reaction? And then there's some other things that we're going to get into maybe later on, like enthalpy of formation and oxidation states of the chemical, and the types of bonds that it'll form. But I think it gets the key word at this point is, does it or doesn't it react, or does it or doesn't it burn? Those are the basic chemical properties of something. Okay, so to wrap up then, we're going to look at changes, and we're going to see how we can do at identifying different changes as either physical or chemical. So let's review. Mr. Hunter, a physical change would involve what?
Something that is observed without actually changing the substance. Well, I can't spell. S-E-R-V. Observed without changing substance.
So it's still the same thing at the end that it was at the beginning. It would have the same chemical formula.
These things are horrible to write on.
All right, and then a chemical change is going to be one
that you observe something that the substance is actually changing.
So the substance is changed when the change happens into one or more new things.
That is correct. And excuse my handwriting.
So it's chemically changed. So all right, so we're going to run down a list here of some different changes that we can have. What I thought we could do is...
All right, so I cleared the board, and let's start going over some examples.
So, Mr. Hunter, I take some iron shavings and sand, and I dump them in a beaker together and stir them up.
I will go with a physical mix because I can physically separate the iron from the sand. So I'll give that as a physical mixing.
Okay.
And you can also see iron and sand as separate entities as well if you use a magnifying glass.
Okay, so let's give you one that's a little more of a challenge then. All right, I take an ice cube and I throw it on a hot surface and I melt it into water.
Okay, we're changing solid water into gaseous water, and that would still make it a physical. So ice to water vapor. Still physical because we're still H2O.
Okay. So we take a fuel like methane gas, CH4, in our Bunsen burner, and we combust it with oxygen.
We're combusting with oxygen, and we're going to make what? CO2 and water. So I'm going to make methane plus O2 yielding CO2 and water as a chemical change.
So once it's
done, it's done. We can't go back easily. Please.
Okay. So how about boiling water? So
boiling
I take
water?
some water out of the tap and I put it on the hot plate and I bring it up to a boil.
That would be much like the ice to water vapor. This would just be a liquid to water. So it's going to be the same thing. Physical. Liquid H2O to vapor is still going to be a physical change.
Okay, so here's one. I pour some water out of the tap in a beaker, and I throw in several spoonfuls of sugar, and I stir it, and I dissolve that water. I mean, the sugar disappears. What kind of change is that?
Well, if I'm dissolving sugar into a water, that thinks to me would be like a homogeneous mixture or homogeneous mixture. So I'm going to go with a physical mixing again. So sugar plus water is going to be physical still.
Or maybe, how about baking a cake? Okay, so Mr. Hunter, you'll like this one. It's right up your alley.
So is the last one.
We explode a firework, like some kind of firework that gives off, brilliant flames and colors.
Fire. Okay, so firework exploding. Anytime you usually have fire, you're taking one thing, mixing it with O2, and making another thing plus light and fire, which makes that a chemical reaction. So a firework would be a chemical. You're taking that powder, you're combusting it with O2, and you're turning it into CO2, water, and some kind of metal oxide powder that gives us the nice colors.
Okay.
All right.
I think we've hit them.
In this last slide, we want to know if it's chemical or physical, and we're going to ask you this question on the reading quiz. So just watch. All right. Figure out if that's chemical or physical change, and we'll find out on the reading quiz. Have a good night.
See ya.